This is Chapter 3, Lecture 3. We're on page 32 in the notes, and we are discussing mixtures. A mixture is a combination of two or more substances in which each substance retains its individual properties. The composition of a mixture varies. So if you think of a salad, it can have varying amounts of tomatoes throughout it. Mixtures can be separated physically. So if you are not a tomato lover, you can take the tomatoes out. And substances have the same properties as when they are separate. So a tomato is a tomato, whether it is in the salad or it is not. Examples of mixtures: salt water. If you let the water evaporate, the salt is left behind. Iron and sulfur mixed. The iron stays magnetic, even when it's mixed with sulfur. And the aforementioned salad. A mixture can be heterogeneous. In other words, it does not blend smoothly throughout, and the individual substances remain separate. A homogeneous mixture has a constant composition. In other words, it has a single phase. It is also referred to as a solution. We have to know a homogeneous mixture is a solution. An aqueous solution is when the dissolved substance is dissolved in water. Examples could be Kool-Aid or antifreeze in water. If we are an aqueous solution, the formula will have the symbol AQ, where AQ means it is dissolved in water. So NaClAQ is salt water. If we turn to page 33, mixtures can be separated by physical properties. And we need to know a couple of ways of separating a mixture. Filtration uses filter paper to separate a solid from a liquid. Distillation is a process by which a homogeneous solution can be separated based on boiling points. If one substance boils at 40 degrees Celsius, the other at 100 degrees Celsius, then we just need to make the temperature between 40 and 100 degrees. And the lower boiling point substance will boil away, and the higher boiling point substance will stay. Crystallization is the formation of a substance from a solution. As the water evaporates away, the substance crystallizes out. Turn to page 34. Turn to page 34. Sublimation is a process by which a solid changes directly to a vapor without melting. An example is dry ice, which is CO2 gas. And finally, chromatography is a technique for separating substances by having a liquid get drawn out across a paper. The components with the strongest attraction for the paper will travel the slowest. And finally, on page 35, we're going to discuss elements and compounds. Remember, substances are classified into two groups. Elements are the simplest form of matter. They cannot be broken down chemically. Into simpler substances. They are the building blocks for all other substances. Elements are composed of atoms. Examples are gold, silver, mercury, helium, anything on the periodic table. Compounds are two or more elements chemically combined. Compounds can only be separated by chemical means. Compounds are composed of molecules, if two nonmetals combine, or formula units if a metal and a nonmetal combine, and I'll discuss that in class. Examples: salt, sodium chloride, water, C3H8 propane, NH3 ammonia, C6H12O6, which are simple sugars. So as we see, compounds have formulas. The properties of a compound are different from the elements that it's made of. Water, which is H2O, is composed of hydrogen gas and oxygen gas. Hydrogen gas explodes. Oxygen gas supports combustion, but we all know that water does not support combustion. Salt, NaCl, is composed of sodium, metal, and chlorine gas. Sodium metal explodes in water. Chlorine gas, if you breathe it enough, can kill you. But salt, we know we use every day on our food. So the properties of the compound are different from the elements that make it up. And that is the end of the lecture. It's also the end of chapter 3. So we shall see you in class.